Hi, folks. Welcome back to 1.5 Part 4. And so if you haven't seen the Part 3 video, I'd encourage you to go back through it or go back to it just to make sure that you've got an idea of why we're able to write down the things that we're just about to write down, okay? So in graph transformations, all right, it turns out that no matter what our function is, if we write the equation in a certain way, we can actually tell what that graph is doing. And what I mean by that is we have that original graph, the parent functions that we've been talking about. And all of these transformations actually tell us about how things are shifting or stretching or compressing, okay? And so we have this A that we saw in the activity, the Desmos activity, right? And then we also have this B here, and we have this C, and we have, last but not least, we have D, all right? And so these four numbers, when we put numbers in the A spot or the B spot or the C spot or the D spot, they do different things to our graph. But the F part is here, F of X, because we can actually do this for any kind of function, all right? So we keep it general. So let's talk about what each one of these letters does, okay? That's why we have a bunch of space down here. So what does A do? All right, so A is something that we call vertical stretch, okay, or compression. So that's not how we spell that, or compression, okay? So it takes our function and it pulls it out, or it sort of makes everything shorter, okay? Now the vertical stretch happens when the absolute value of A is greater than 1, but the compression happens when the absolute value of A is between, well, sorry, absolute value of A is less than 1, okay? So the compression is like 0.5 or 0.7, but the stretch would be like 1.5 or 1.7, any number bigger than 1, okay? It also does something else. So if A is negative, right, so negative A would mean that there's a reflection over the x-axis. All right. And these ones we multiply y values, but keep x values. All right, so we change the y values, but we do not change the x value. All right, so that is what we do for A. Now, in our exploration, we actually then went on to the letter D. All right, so we'll do that here as well. Now, D, as it turns out, is a vertical translation, right? And translation doesn't mean we're changing it to a different language, but translation here really means that we're shifting things up and down, okay? And this is that very last number at the end, all right? The vertical translation here, if we have a plus D, we're going to move up, but a minus D will mean we move down, okay? And in this case, we add or subtract two y values, but keep the x values. Okay. So the A and the D, those all change Y values and either stretch or shrink the function, or they shift the function up or down, okay? Now, B and C are also some sort of stretch, compression, or translation, except they're not in the vertical direction, they're in the horizontal direction, okay? So let's start with B here. Right? B is what we will call a horizontal stretch or compression. Right? And it turns out that we get a stretch when the absolute value of B is less than 1, and we get a compression when the absolute value of B is greater than 1. Okay, now that seems backwards from the vertical one, and it is. Okay, so if I saw B as a number like 10, I'm not stretching it by 10, I'm compressing it, I'm squeezing it in 10 times as close. Okay, now the negative B here, all right, that's also a reflection, but not over the x-axis, but a negative B reflects over the y-axis, okay? And we don't multiply our y values and keep our x values, but we multiply our x values and keep our y values, okay? All right, so we are multiplying our x values and we are keeping the y values. All right, and that, my friends, I think we had done in the yellow, so that's our B. And last but not least, we talk about C. And C is not a vertical translation, but a horizontal translation. All right, now I'm going to grab what I had written over here. We're going to duplicate it, and then we're going to modify as we need. Okay, so we don't want a vertical translation, but it is a horizontal translation. All right, instead of the plus and minus D, we have, if I see plus C in the equation, we're going to the left, but a minus C means we go to the right. We are adding or subtracting not to the y values, but the x values, and we are keeping the y values. All right, so this should be a nice summary of what we saw in that video part 3. Okay, but now we're going to apply these to questions and actually see how we can use them to graph functions that ordinarily might seem like, wow, how does anyone know what that picture looks like? Okay. All right, so we're going to start here with example 4. Example 4, given f of x equals negative parentheses x plus 3 squared plus 4. What we're going to do is we're going to go ahead and graph this, all right, in 1, 2, 3 different steps, all right? But before we do those steps, we have to identify the parent function. And so in here, I notice that we've got a squared. And so what that means is my parent function is actually y equals x squared. Okay, that means this is the picture that I'm starting with. So let's start with a parabola, and I'd like us to mark off 5 exact points. Okay, so I know 0 squared is 0, 1 squared is 1, and 2 squared is 4. But I also know that -1 squared is -1, and -2 squared is 4. And I want to connect these with a smooth U shape so I can see that I've got a parabola. okay? When you work on that quiz that you're going to turn in at the end of week 1, it would be really important that you plot those exact points, okay? All right, now what happens first, okay? So someone walks up to you on the street, they give you the X. The first thing you're going to do is take care of this +3, okay? So if we think about the order in something that's important, we're going to have to take care of this +3, okay? We would square it and then take care of that minus in the front. And that's really a -1 for the A. And then last but not least, we're going to add 4. Okay? So we're going to think about this as the first thing we do, the second thing we do, the third thing we do. Right? And so if you notice down here, we've got 3 more grids. Here's where we're going to put the first transformation, the second one, and then the third one. Okay? All right, first one up, X + 3. So in our equation, we actually just want to write Y equals parentheses X + 3 squared. And underneath where it says graph transformation, we're going to write that +3 moves the graph to the left 3. Okay. And so when I graph that, I'm going to take all 5 points that I drew here, and I'm going to move every single one of them to the left 3. So I've got my vertex is now here. I've got this point, and then these 2 that have a Y value of 4. And again, we can connect these with a nice smooth curve. And now we have the first step in our graph transformation. Okay. The second step is we are reflecting it over the x-axis, right? And I know that because my equation is now y equals negative x + 3 squared. Okay, so this +3 moved it to the left 3, but this negative is going to be a reflection, so reflect over the x-axis, okay? All right, reflect over our x-axis means I'm going to take all of these and I'm going to multiply the y values by -1, and I'll get a picture that's facing down. So 0 times -1 is 0. 1 times -1 is here. And 4 times -1 is here. And now I can connect those with a nice curve. And now we've got our second graph transformation in there. Okay, now let's go back and see what we had. So far we've done the first one, the second one, and now we have to add 4 to all the y values because that's our D. Okay, so we're going to move up. We're going to move up 4. So we get y equals negative x + 3 squared plus 4. And so I'm going to take all of my y values and I'm going to add 4. And now I've got my final picture. So I've got my negative A, my shift to the left 3, and my vertical shift or translation up by 4. Okay. And if we look at all the pictures here, we can see we have our parent function. We moved it to the left 3, we reflected it, and then we moved it up 4. Okay, so when you turn in your quiz this week, it would be really important that a question like this that you're able to do point by point and show me what step you're doing where. Okay. All right, we got a couple more examples. Let's get through those. Example 5, all right, we've got given f of x equals absolute value of 3 minus x minus 2. Now, the parent function here is our y equals the absolute value of x. And so before we actually talk about the transformations, let's go ahead and we're going to draw our absolute value graph, all right? So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, but also negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5. And unlike our previous example, we should end up with a V shape and not a U shape. Okay. So we've got a nice picture right there. That's our absolute value. Now, before we do anything else to this, I want to bring a lot of attention to this, okay? This minus sign and how we have the x right after that, that is a clue that we actually need to rewrite what we have. And here's what I mean by that. Absolute value of negative x plus 3 minus 2 is the same thing. But now I actually need to factor out this negative. So absolute value, negative 1, parentheses, x minus 3, close it, minus 2. Oops. So this step right here, where we factor out b, is so important. So important that I gave it 4 pink stars, but if I could, I would give it like a bazillion pink stars. This is an important step, okay? But now that we have that, let's go ahead and color code and see which graph transformations we have, all right? So first off, we've got this minus 3. Second, I have a b value of negative 1. And last but not least, I have a d value of negative 2, okay? All right, so our first thing, we are going to say y equals absolute value of x minus 3. And this minus 3, that shifts the graph to the right 3. Okay, remember the horizontal ones are the opposite of what we think. So let's take our graph. We're going to move everything over 3. And I think the easiest way to do that is to move the vertex and then move everything else. Okay. All right, there's my graph shifted to the right 3. Now I have this negative 1. And when the b is negative, that's not a reflection over the x-axis, but rather it's a reflection over the y-axis, okay? So let's write that in. We're going to reflect over y-axis. And that looks like y equals inside the absolute value, negative x minus 3. So now I take this picture and I'm going to flip everything to the other side of the y-axis. So where does our vertex go? It was at positive 3. Now the vertex is going to move to negative 3. All right, and every point will now be reflected as well. And so I end up with a V shape like this. All right. Last transformation here, this minus 2. Minus 2 is a D value. So that means we're moving the graph down 2. All right. So down 2, y equals negative x minus 3 minus 2. So our negative, that's our reflection. Minus 2 is our last transformation, but we don't want to forget what we started with this minus 3. Okay, so now I'm going to move everything down 2. 1, 2, and then make my v from there. All right, so there we have it, our example 5, where we've got all these points plotted, we've listed out the specific graph transformations, and we've shown what order they happen in. Okay, now just as a reminder here, when you submit something like this on a quiz, I do want to see all the points. Or if you draw something like this on a test, I want to see all the points. If you don't draw all the points, I don't give you all the points on the problem, okay? So I want to make sure that's really clear. The way I'm modeling this problem is the way that I would like us to do these problems, okay? All right. I believe this is our last example. And this one also should have some pink stars because I see this minus sign and then my x next to it, okay? So let's take care of that now, even before we do the parent functions. All right, so we're going to switch the order. Negative x plus 2 cubed minus 1. And then we're going to go ahead and factor out that negative. So negative x minus 2 cubed minus 1. All right, now we've got our c value, our b value, and our d value. Very similar to the previous question, okay? But what's different? I don't have an absolute value this time. In fact, I have a cubic function, all right? So our parent function this time looks different. We're starting with a different picture. And for the cubic ones, the only points I really want us to graph are 0, 0, 1, 1, and negative 1, negative 1. But to make sure that we make it got a little curve to it and not just a straight line through that, okay? All right, what are we going to do first? We're going to do the negative 2, then we're going to do the negative b, and then we're going to do that negative 1, all right? Now that negative 2 means our equation is y equals x minus 2 cubed, all right? That is going to go to the right 2 units. And so I can take this picture and move everything to the right. 2 units. And same thing, I want to make sure that I'm not connecting with a straight line, but a nice curve like that. Okay. Now, it might be helpful for some of us to sort of keep track of that middle point, all right, so that we can see where things are moving to. All right, negative b, that means that I reflect over the x-axis, all right? So y equals negative x minus 2 cubed. And that means that this pink point is now going to be on the other side of the, I meant to write y-axis, other side of the y-axis, all right? So 1, 2, and then here, and then here. And so now it's sort of going from the top all the way to the bottom, right? And this is where that pink point landed. All right, last piece here, that minus 1 just means that I need to take my picture and slide it down 1, okay? Now, I forgot the extra box, so we'll write it down here, -1, y equals negative x minus 2 cubed minus 1. And I'm going to cheat, and I'm just going to draw it right on this same graph, all right? But I'll make sure you all have a second graph. So down 1 unit, down 1 unit, down 1 unit. And now when I connect them, I end up with something like this, and that pink point now has moved down 1 unit. Okay, let's get this all on one page so you can see it. But that is our last example for the graph transformations, and you'll have a chance to practice the concepts as well as the actual graphing in the quiz for this week, as well as the MyOpen Math for this section. All right, thanks so much. See you later.